Welcome back, everybody. In this video, we're going to be taking a look at our next topic, which is reflexive ACLs. Now, reflexive ACLs are going to add a little bit of active state monitoring. So think of this as pretty much your first level of active monitoring of what's going on. So we've taken a look at the standard ACL, the extended ACL, logging with that, and then time-based options. So what we're going to be doing in this video is we're going to actually remove the access list from gig 0/0. So do show run interface gig 0/0. And we're going to go to interface gig 0/0 and type in no. That's a lot of other characters. No, and pull this off. Because what we want to do is we want to basically, we have to create a couple of new access lists, and we're going to apply one inbound and one outbound, and this is going to allow us to track egress traffic and ingress traffic respectively and see exactly how that comes into play. So to keep it simple, and you can get pretty granular with how this actually comes into play, but what we're going to do, and it's actually pretty simple, we have to create an access list, an extended access list, and we're in this particular case here, we're going to name this one outbound. So this is going to be traffic that's going to be passing through the router outbound. So we're going to say outbound, and I'm going to just hit the enter key. And so I'm going to match on the most common traffic as it's leaving the device. So we're going to type in permit TCP, TCP any, and then we have to add this reflect command. So reflect allows us to add in reflexive access list creation. So basically it's going to be a dynamically created access list that's created when traffic matches on a particular entry leaving the device, so the traffic can come back in. So think of it like the context-based access control or zone-based firewall, where you have to allow the traffic through and then on the return flows. But if your return flow, if you don't have an existing flow, when a return flow comes in, the traffic actually gets dropped. So in this case here, we're going to call the state ACL, which we haven't created yet. And we're going to go ahead and specify the timeout here. And the timeout by default is 300 seconds, but we're going to set it to 30. Now that we've done that, we're going to do the exact same thing, but for UDP traffic. UDP, then we'll do it for Icmp, and that should be pretty much anything that we have. Now we're also going to create an access list that for inbound traffic, so the return flows. So we're going to type in IP access list extended, and we're going to say this one is called inbound, so it's easy to follow. And here we're going to say evaluate the state ACL, which is going to be the dynamically created access list that when traffic goes out that is created. We're going to evaluate that, then we're going to type in deny IP any, and log it. So what this is effectively going to do for us is it's going to allow the communication for the device to go through the device. So, I'm sorry, the traffic to go through the device and then reply. Now, when we do the return flow, if we're going to match on this, we're going to check this entry first. Okay? So when we go out and we come back in, the state table is checked. If there is not an existing flow, the traffic will get dropped, which is why we have the deny IP any. So now I get to go to the interface, do show IP interface brief, on interface gig 0/1 and type in IP access group, and we'll type in inbound, inbound, in, and outbound, out. Pretty straightforward stuff for the most part. Now that we have that in place, we can come in here and type in show IP access list, and we get to name this the access list of state. Now nothing's in there currently, but if we were to go in here and open up a web page to say google.com, that should work. And if we come back over here and hit the up arrow, the access list of, oh, we have to call it state. So state. There we go. So, sorry. Capitalization, or what's the word I'm looking for? Caps lock does matter. So what we have here is active connections going out. So we have a couple of DNS records here, and then we have some TCP flows that are going out. Now that's TCP and UDP. Can I ping google.com? Yep, sure can. Hit the up arrow. Now I should have some ICMP messages in there. And notice that after a period of time, they get yanked out, which is good, right? Now if I do a continuous ping to Google, -T, and hit the up arrow, we should have some ICMP going out, and we should also have, over here, we'll go to, now does this affect anything inside the network? No, not at all. It wouldn't need to. But if we go back over here to the new tab, and we type in new tab, and we type in dogpile.com, that should also resolve. But this one's going to come back. It's going to take a little bit longer. But if we hit the up arrow, we're going to start to see lots and lots and lots of sessions open up. But the cool thing about it is all this traffic is being evaluated, right? So let's say, for instance, I went to, let me go to my computer. Here, I have my command prompt. And let's say, for instance, I wanted to show IP interface brief. And let's say I wanted to ping 100.64.21.11. Destination network unreachable. So what you're seeing right here is an inbound deny ICMP. So what does that mean? It means that because I didn't already have an existing connection in the state table to allow ping, that it's not going to allow the traffic to come back inbound. So that's why my ping dropped. So I'd have to go to the show IP access list, and I'd have to look at the inbound one, which is right here, which is evaluate state and deny IP any. I'd have to go to global config and IP access list extended inbound, and in here I'd have to type in like 15, or I'm sorry, I'd have to type in 15, and then I had to type in permit ICMP from any source to a destination of host 172.6 or 100.64.21.11. So if I did that, let's try this again. Now it works, but only because of the fact that I'm allowing, do a show IP access list. I'm allowing the ping reply to happen right there. That's the only reason that's actually happening. Now, you wouldn't have put that above the you could put it above the evaluate, but the evaluate command or entry in that access list is there on purpose. It's there to actually watch to see if the traffic is being matched on and the return flow. So traffic that does not match the state table entries should be reapplied, and I'm sorry, that's the wrong way to explain it. Traffic does not match in this one here, so it did not come from the inside of the network going outbound. Then I would need to say, okay, if it doesn't match here, continue processing. Then come down to here. If it's a ping flow coming from any particular source to the destination of myself, so 100.64.21.11, then you would allow that traffic to come through. Any other traffic besides that, you're going to drop. So like if I tried to telnet from, let me go ahead and pull up my telnet from my home computer and type in 100.64.21.11, 23, and I telnet, and click on open, you're going to see inbound dropped, right? Because it's not allowed through. So this is one of those things that comes into play where when you're looking at and understanding how the access list works, this is basically how a reflexive ACL comes into play. Pretty straightforward for the most part, but in one of those situations where if you're not careful with it, that could cause a problem. So this is one of those times where when you're dealing with access lists, and I'll go ahead and I'll allow that through too, you have to understand how the access list processing comes into play. So IP access list extended and then inbound. We're going to type in permit TCP from any source to a destination. Actually, let's be even more specific. We'll say 16 permit TCP from the source of host 10.255.10.20 to a host of 100.64.12.11 equal to 23, which means that the traffic coming from my PC to R11 has to be telnet. We'll go ahead and add that. We'll do a show IP access list. And then in that access list, I do have an added entry in the ACL. Restart the session. And I am still denied, which should allow it to come through. Oh, I have the wrong IP. That's why. 21.11. So IP access list extended, inbound, no 16, permit TCP host to this, except for I need to come back to this one part here and type in 21.11. Try this one more time. Restart session. Why am I not? Close that out. I should be able to hit it. (100.64.21.11) to 23. Yeah, it's being refused. Do show IP access list. I'm permitting the traffic, but for whatever reason it's being dropped. That's weird. Do show run section line. Oh, do show IP access list. So on do show IP access. So on this one here. So the problem isn't this ACL here, it's this ACL up here. So on the standard IP, let me exit out of here, IP access list standard, and then this ACL, we're going to type in, we'll say 15 permit the 10.255.10.20 network to come in. So we'll try this one more time. This time it should work. Restart session, and there we go. Rob and Cisco. If I could type, there we go. So everything's working the way it needs to. We type in who, and I'm connected to it the way that I need to be. And if we come through here, we do a show IP access list. We're going to get hits on both. We're going to get a hit here, and we're going to get a hit because this is a host match. That's actually kind of interesting. I'm actually kind of glad that worked out the way that it did, because even though the 15's above the 10, it's a more specific match. So the ACL goes, okay, you're a host-specific match, not a subnet-specific match. So I'm going to have to go ahead and let you through. But we also see that the telnet connection was allowed through as well. So Again, the interface ACLs are processed before the VTY line ACLs are processed because of the order of operations. Axis list, then control plane. So until next time, guys, thanks so much for stopping by, and we'll catch you guys in the next video.